In this video, we will do another multi-step dimensional analysis problem. So we're going to start as usual by analyzing the problem, trying to find what is given to us, what are we trying to find, and what pieces of information are going to connect these so that we can ultimately get to where we're trying to go. This problem states a runner wants to run 5 miles. Her running pace is 4.2 kilometers per hour. And it wants to know how many minutes does she need to run in order to reach that distance. It also provides us with a conversion between miles and kilometers, so we're probably going to need to use those pieces of information. As usual, I'm going to start by identifying what is given in the problem and what we're trying to find, and then I'll identify some conversion factors to get us there. So I see that it's telling us a runner wants to run 5 miles. And if you recall from the previous videos, whenever I'm looking for a given, it's going to be a number that's off by itself. So not something that would be part of a conversion where there are two different units involved. So this only has one unit, miles. It's telling us she needs to run 5 miles. So that looks like a given value. Finding what we want will be relatively straightforward because it's usually in the form of a question. This is asking how many minutes. So what we're trying to find is the number of minutes that she needs to run. Now we do have some extra information in here. So there's a conversion between miles and kilometers. So we'll probably need to use that. And then it's giving us her running pace, which is 4.2 kilometers per hour. So the 4.2 kilometers per hour, we could write in the form of an equality. And if you recall, anytime we have an equality, we can turn that into a conversion factor. So I could say in 1 hour, she will run 4.2 kilometers, or I could turn that equality upside down, put kilometers in the numerator and hours in the denominator. I can do the same thing for the conversion between miles and kilometers. So I could say that there are 1.609 kilometers in 1 mile. Or we could flip that conversion upside down and put miles in the numerator. So which version we need to use will really depend on how we set up our problem and how we get those units to cancel. So it might be helpful to start off by just kind of drawing a roadmap of where we're trying to go. So we know that we have 5 miles, and somehow we're trying to get to the number of minutes. Now, we don't have a direct connection. There's no conversion that will directly take us from miles to minutes, but we do have some other information that can take us to places in between. So if I look at everything else that is given to me in the problem, I need to find something involving miles. And there is a conversion right here that takes us from miles to kilometers. So, okay, great. That will get us to kilometers. But then what do we do from there? Ultimately, we're interested in the number of minutes, so somehow I'm going to have to get rid of those kilometers, which means I need to find another conversion that involves kilometers in some way. And there's a conversion right here. So this can take us from kilometers to hours. Okay, perfect. That gets us to hours. But ultimately, we're interested in the number of minutes. So we need to have some way of connecting hours and minutes. And that's not explicitly given to us in the problem, but that's okay because we know how many minutes there are in an hour. So sometimes there will be little pieces of information that are missing from a problem that we need to fill in ourselves just based on what we know. And we know that there are 60 minutes in an hour. So there is one more connection here that we can draw up. We know that 1 hour is equal to 60 minutes. And then we can turn that equality into a conversion factor. So we could put an hour in the numerator, or we could put it in the denominator. We can flip that conversion upside down. Okay, now it looks like we have everything we need to solve this problem. So I'm going to use this roadmap and I'm going to go in order. I'm always starting with what is given and then working my way toward the unit that we need. So we're trying to ultimately get to number of minutes. So I don't care about miles. I want to get rid of that. And whatever unit I want to get rid of, it has to go diagonally in order to cancel. And since here miles are in the numerator, I'm going to need miles in the denominator, which means I'm going to look at all of the conversions I have, and I'm trying to go from miles to kilometers right now. So I want to get rid of miles, which means miles need to be on the bottom and kilometers need to be on top. So that's the conversion factor I'm going to use, the one on the left. I will put 1 mile on the bottom and then 1.609 kilometers up top. And now miles that are diagonal from each other, those cancel out. Okay, we're definitely not done because we're trying to get to the number of minutes. So there's another conversion we need here. So we're not really interested in kilometers either, which means I'm going to have to get rid of that. So next, kilometers will go on the bottom. So we are here right now and we're trying to get from kilometers to hours. So I need to find a conversion that connects those two. And there's one right here. So I see that kilometers will need to go in the denominator and hours will need to go in the numerator. So I'm going to use the left version of that conversion factor, and I will put 4.2 kilometers on the bottom and 1 hour up top. Now I see that kilometers are diagonal. Those are going to cancel, and we're now in hours. So there's just one more step we need to do here, and that is to take those hours into the number of minutes. So since we're trying to cancel hours and they're in the numerator, next I need to put hours in the denominator, and then I can end with the number of minutes up in the numerator. And if I find a conversion factor that allows me to do that, it will be this one, where hours are in the denominator and minutes are in the numerator. And I'll just plug those values in. And now I see that hours are diagonal from each other and they cancel. So everything here cancels out, and ultimately we will be left in minutes, which is exactly what we're trying to find. So when we're plugging this in at the very end, keep in mind that everything up top gets multiplied and it gets divided by everything on the bottom. So I'm going to plug that in. And I'm doing 5 times 1.609 times 60. I'm ignoring the 1 because it's not going to change anything. And then I'm dividing by 4.2. And that is giving me 115 minutes. And then I just need to be a bit careful with significant figures. And if I look back up in the problem, it looks like we're using 2 sig figs, so I'm going to need to round that to 2 sig figs. So I'll call that 120 minutes. And that is it. That's our multi-step